Hello everyone, welcome back to the sixth term examination paper. We were doing the past year questions and this is the second question that I have for you in the series. So in this section there are a lot of questions and they are divided into parts. Alright, so here in this video we will be doing the first part, and in first part there is a bit of information given and there are two subparts. Alright, the information is that is given states that if you have a coordinate a comma b where a and b are rational numbers, then you would call a comma b an integer rational point if both of them are integers. Okay, now this follows a bit of common sense because rational numbers include all of the natural numbers, whole numbers and integers, right? So the question wants you to designate a comma b as integer rational if a and b are integers. If they are not, then a comma b will be designated as a non-integer rational point. Now in the second point it is said that neither a nor b, alright, so both of them should not be an integer. Even if one of them integer, that should be an integer rational point, right? So if neither of them are an integer, then it will be called a non-integer. If it is an integer rational point, then both a and b should be integers. So that means if one of them is integer and the other one is not, then we will not be able to classify them. Okay, it's either both or neither nor. Okay, with that being clarified, let's move on. So we have to look into this equation, right? X square plus y square equal to 1. Now you know that x square plus y square equal to 1 can be a circle, or you can also think of it as a right angle triangle, right? Where let this be any random angle, you have x here, you have y here and 1 here. So Pythagoras theorem will also be giving rise to this equation in subpart A, x square plus y square equal to 1, because Pythagoras theorem states that perpendicular square plus base square equal to hypotenuse square, and there the hypotenuse is 1. Alright, so these are the two interpretations of x square plus y square equal to 1. Now what do they want? Write down an integer rational point and a non-integer rational point. Okay, for integer rational point we just have to place them as integers, right? So I can say let x equal to 0, y equal to 1, right? As 0 square plus 1 square equal to 1, therefore 0 comma 1, or similarly 1 comma 0, right, is an integer rational point. Sorry. Okay, that portion is done. Now once we have done that portion, now we will be looking into obviously the second portion. The second portion says write down an integer rational point on the circle. Okay, before we move into that we have to do the non-integer rational point as well. So for the non-integer rational point we will take the help of this second interpretation that we had. Okay, so this is part A. For this one we will be looking into any Pythagorean triplet. Okay, so any Pythagorean triplet you can think of will work as a solution. So the easiest and the smallest Pythagorean triplet is 3, 4, 5, right? So consider the Pythagorean triplet 3, 4, 5. Now you know the properties of Pythagorean triplets, right? If a comma b comma c is a Pythagorean triplet, then a square plus b square equal to c square. So here we know 3 square plus 4 square equal to 5 square. And also recollect the fundamental property of Pythagorean triplets is that any multiple of Pythagorean triplets are also Pythagorean triplets. Okay, now we usually think in terms of integer multiples, but any rational multiples also work. You know the logic hopefully, because if a square plus b square equal to c square, then any ka square plus kb square will be equal to kc square for all k, right? Any multiple that you attach to the Pythagorean triplets will give you another Pythagorean triplet. So scaling this triplet hypotenuse equal to 1, we have, so 3, 4 and 5, 3 and 4 are the perpendicular and basis, can be interchanged, and 5 is the hypotenuse. If we want to scale them down to 1, we will have 3 by 5 comma 4 by 5 comma 5 by 5, which is equivalent to 3 by 5 comma 4 by 5 comma 1, right? So I can write therefore 3 by 5 comma 4 by 5 or vice versa is a non-integer rational point on x square plus y square equal to 1, right? So that concludes the first part. Then we have part B. Wait, I designated this as part B, but this was just the second part of the first question. Part B says write down an integer rational point on x square plus y square equal to 2. Fine. Now again this one is easy. Let x equal to 1 and y equal to 1 as 1 square plus 1 square equal to 2. 1 comma 1 is an integer rational point, right? There are no confusions about this one. This should be easily understandable. Alright, now the second portion is dealing with simplifying a trigonometric expression, right? Simplify this and hence obtain. So that means our first order of business would be to simplify this, right? So let us take out our tools and find the simplification of this. So it will be cos theta plus root m sine theta whole square plus sine theta minus root m cos theta whole square, right? So just square it, we'll get cos square theta plus 2 root m cos theta sine theta plus m sine theta square, right? We should write sine square theta because root m becomes m and sine theta becomes sine square theta plus sine square theta minus 2 root m cos theta sine theta plus m cos square theta. Now these two eliminated, cos square theta plus sine square theta. This is the second part as well. If I take m common, sine square theta plus cos square theta. Now both of these are 1, right? So I can write it as 1 plus m. Alright. Now I hope you understand why this question obtain a non-integer rational point on x square plus y square equal to follows this. Because if I set m equal to 1, then what do we have? We have cos theta plus root of 1 is 1, right? Cos theta plus sine theta whole square plus sine theta minus cos theta whole square is equal to 1 plus 1 equal to 2. This means that cos theta plus sine theta, this thing, and sine theta minus cos theta, they will satisfy this equation, right? Because their squares add up to 2. From here we will get a non-integer pair. Okay, so if you want, you can use the trigonometric ratios from this triangle, or you can set any value of theta and obtain the required equations. Alright, so do not use 45 degree because that will make this part to be 0. You can just use 30 degree. So let theta equal to 30 degree, then cos 30 plus sine 30 whole square plus sine 30 degree minus cos 30 degree whole square equal to 2. Therefore cos 30 plus sine 30 and sine 30, it's better to write it like this, is a non-integer pair, non-integer rational point, sorry. Now calculate these values. Implies what is cos 30? Cos 30 is root 3 by 2, right? So just select root 3 by 2 plus half and half minus root 3 by 2. Let us simplify it. Root 3 plus 1 by 2 comma 1 minus root 3 by 2 is a non-integer rational point. Okay, so this is one way. For the second way, you could have just used the cos theta for this particular triangle, right? So in this particular triangle, if I take this to be 3 by 5 and this to be 4 by 5, so I will have one more set of sine thetas and cos thetas, right? You can calculate sine theta from there and cos theta from there as well, isn't it? So using the triangle we had, I can calculate cos theta. Cos theta will be, we have base 4 by 5 divided by the hypotenuse 1, which is basically 4 by 5, and sine theta, same logic, 3 by 5 divided by 1, which will give us 3 by 5. Therefore cos theta plus sine theta, this one will give us 7 by 5, and cos theta minus sine theta, no, it's sine theta minus cos theta, right? This one would give us 3 by 5 minus 4 by 5 equal to minus 1 by 5. Alright, so again we will have 7 by 5 comma minus 1 by 5 is a non-integer rational point. Okay, I showed you both the techniques of solving the B part of this question, because there is no fixed way, right? If there are two ways, you should rely on whichever method comes to you first in the exam. Alright, there is no guarantee which one will pop up in your head, so I showed you both the methods. I hope you understood this question. The question is again framed quite easily. All of the hints are given within the framework of the question. You just have to follow them step by step and do the calculations correctly. Okay, you need to have a basic idea of what circles look like, how their equations develop, how we can derive that equation, how we can relate the equation of circles to the equation of a triangle in form of Pythagoras theorem, right? Because you can select that point in the right angle triangle as a center, and then you can form a circle around it. So if the hypotenuse is taken as the radius, if you fix that, then the locus of a fixed point around a center will be a circle, right? That is why you can interpret this x square plus y square equal to 1 in two ways. Same thing with x square plus y square equal to 2. We just put the values in such a way that we get our desired outcomes. Now we did this for m equal to 1. You will see that in the subparts that are upcoming, which we'll discuss in the next section of this question, we will have to deal with x square plus y square equal to 3, as well as some different random numbers. Alright, so I'll see you in the next one. There we will discuss the second subpart.